So today is my 875th daily trash pickup here at my local park. It is Thursday, December 16th, 2021. Got about a half bucket of trash here in the gorge section of my canyon, where, as you can clearly see, the Tuesday flash flood event has certainly made its mark. This is pretty crazy out here. There are new logs that were not down here, and I do not recognize whatsoever, that are pretty large, that have made their way from above our waterfall, which we cannot get past physically. It's just, there's no way up there. The destruction is pretty extreme. Today's video is going to be a much longer one than normal. Twitter only gives me 2 minutes and 20 seconds to post my videos. And so I'm going to post this one onto YouTube so I can say all that I want to say, because today we're going to talk about flash floods. This is my special interest for this week because, of course, we got a huge flash flood in my park, and I'm curious about how this one compares to ones in the past. But I got a lot to say today, so I'm going to go over to this boulder here, and I'm going to sit down, and we're going to talk about this. So, I've really only been in this canyon for 2 of our major flash floods. January 17th, 2019, and December 14th, 2021. In 2019, that flash flood was preceded by about 5 to 6 days of light to moderate rainfall. We got about half an inch to 2 inches of rain on each of those days here in these mountain slopes. Now, if you look up above me here, these things are exceptionally dry and rocky, right? They do not absorb water very easily. So whenever we get heavy rainfall, all the water just finds its way inside these gullies, thunders to the bottom of the wash, and then thunders down the canyon, ripping up rocks and trees and all this whatnot along the path. Well, in 2019, the January 17th storm gave us about 2 to 4 inches of rainfall. It was pretty substantial. And we saw a large flash flood that came down this canyon, and I was here when the actual flood hit, and I got, it on video. It's nowhere as near as big as the 2021 flood just a few days ago. The 2019 rainstorm series then dropped about 6 to 12 inches of rain on our park. 2 days ago, we only got 3 to 7. Here's the big difference though. Those 3 to 7 inches of rainfall came down all in one morning. Those 6 to 12 inches came down through an entire week. And while we did get 2 to 4 inches on that one day, it doesn't matter. What is clearly very important for flash flooding is not having several days beforehand where you get heavy rain, but having very heavy rainfall in a very short amount of time. That's a clear sign that this park is predominantly a semi-arid desert or Mediterranean, and of course that's what we're classified as. But you put 3 to 7 inches of rainfall on these mountain slopes, yeah, you're gonna get an enormous flash flood. And I'm actually very intrigued by that, because I didn't expect that. I thought 2021's flood, I knew we were gonna get a big flood. I knew this would change the park forever. But I just thought it would be a little bit smaller than 2019. I was wrong. It doesn't matter as much. It still is important, but the most important factor is not getting tons of rain in the days beforehand. The most important factor for a big flash flood is tons of rain coming down in a very short amount of time. That is what we're seeing with climate change. Climate change is increasing that risk around the world. Heavier rain is becoming more common. However, when we look at the flash flooding in my park and we look at rainfall records over the last 114 years, the last decade has not featured very many days where we got very heavy rainfall. In fact, there's only 3 days in the last 10 years. December 2014, I forgot the exact day of the month, January 17th, 2019, and of course, December 14th, 2021. The previous decade, the 2000s, saw 13 days where we saw very heavy rainfall, 9 of which occurred during the 2004, hold on a second, yes, they're talking to someone else. Anyways, 2004, 2005 flash flood was extreme. That one put out huge amounts of rainfall in a very short amount of time. There were certain days that year where we were getting 5 to 10 inches of rainfall in just one day. Much more extreme than what we saw on Tuesday, and that was really causing some flash flooding out here. But 2005, while severe, did not deposit some of those ponderosa pine tree logs that I found in the wash well below us. Those ponderosa pine tree logs, as I've discussed before, grow at the top of Mount Wilson, several miles up above us. And the only way for those logs to get all the way through this windy canyon down into the wash is by flash floods. And I checked on Google satellite imagery before and after imagery of 2005, and it was not big enough to deposit those logs where they are currently sitting today. So it was not the 2005 flood that deposited those things there. 1969 was another big year. We got a lot of rainfall that year, and of course a huge flood. I don't know the exact date, but it was in January 1969. We lost a restaurant that was at the bottom of our park, where we now have an overflow parking lot. So there is a record of buildings being destroyed by that flood. Here's the crazy thing though. This is the problem I'm running into while I'm trying to look at some of these flash floods and categorize them. In terms of annual rainfall or even daily rainfall, 1969 does not stand out at all. It compares to 2005, but it also compares to 1980 and 1983 and 1998 and 2001 and 2004, all of which years didn't see the extreme flash flooding that 2005 and 1969 saw. And the reason behind that is because of the rain rates. Here's the problem. Even having daily rainfall is not precise enough. Because if you have 5 to 10 inches of rain over the entire 24-hour period, you're going to get a lot less flash flooding than if you get 5 to 10 inches of rainfall over just half the day. So even daily data is not precise enough for me to determine where some of these flash floods occurred. And that is a real problem that I'm running into. The mother of all flash floods, there's two of them. One is bigger than the other. The smaller of the two happened during a tropical storm, in Southern California, believe it or not, that made landfall in Long Beach in September 1938. We picked up a foot of rain over just half a day. It was intense, and an enormous flash flood thundered through this canyon. But it doesn't compare to 1943. On January 22nd, 1943, a very powerful atmospheric river stalled directly over Los Angeles County. Mount Wilson picked up 26 inches of rainfall in 24 hours. To this day, it remains the North American all-time record for most rainfall in 24 hours from a non-tropical cyclone. And even then, we're only in 4th place, and we're being pitted up against Puerto Rico, Hawaii, and parts of Mexico. Tropical places where they see absolute deluges. And this place is in the number 4 spot. That's incredible. We picked up 15 to 26 inches of rainfall in just 24 hours out here. Where I'm standing, probably where that dead bush is right up there, was probably the water line, I'm assuming. Because think about it. We have ponderosa pine tree logs that were deposited by this flood that are hundreds of feet removed from the bottom of the river, and in terms of distance, and 10, 20, even 30 feet in elevation removed from the bottom of the river in terms of vertical distance. And that's out in the wash. Everything is significantly spread out. Here you're at the bottom of a canyon, bottom of a ravine, where all the water is crunched together in one little spot. I mean, where I'm standing, we were under 40, 50 feet of water. That flash flood was extreme. If that were to happen again today, there would be neighborhoods below this park wiped out. Homes destroyed, people killed, bridges destroyed, roads destroyed. I mean, it would have just been a total disaster. A catastrophic disaster would have struck my area. It's insane. So, how does climate change tie into all of this? Well, this place sees flash flooding. It's part of our ecosystem. Flash floods have occurred here for tens of thousands of years. That is why we have a mountain gorge like this in the first place. Worldwide, climate change is making rainfall heavier. Because our atmosphere is warmer, it can hold more of that moisture, and it can drop it more quickly and have heavier rainfall. Here's the crazy thing. Like I said, the last decade has seen the fewest number of extreme rainfall days in Pasadena than any of the previous decades on record. And these go all the way back to 1906. But here's the problem. I'm using daily data for this. I don't have hourly data. I have 5-minute data from the storm just 2 days ago. I can look at how heavy the rainfall was at 9:05 a.m., 9:10 a.m., 9:15 a.m., 9:20 a.m. I do not have that for anywhere beyond or before about, 2010? So I have no record of these flash floods in terms of how heavy the rainfall was during the event. Maybe rainfall is getting more extreme out here, but it's just not showing up in the daily data. Maybe it would show up in the hourly data if it existed. It does show up in the annual data because 2005 was the wettest year we've ever seen. Despite 1943, despite 1969, despite, what's the other one? 1938. 2005 was the wettest year we've ever seen. 2007, 2021 are the driest years we've ever seen by far. It's not even close. I mean, I guess 2014's in third place, but no. Any year before the year 2000 was nowhere near as dry as 2007 and 2021. So rainfall rates are changing out here. How does that affect flash flooding? Give me 10 or 20 years because I only have 2 points of data now and I need dozens. So we're going to see how that pans out over the coming decades. But for now, I'm going to document this flash flood event. You guys might have seen one of my videos. We have kind of a man-made structure where the surface, the bottom of it is in several steps. And it might be a very good area to use as a reference point for measuring the size of flash floods. Both during 2021 flash flood and 2019 flash flood, I got a video. I'm gonna recreate it, where I'm following the water at the same pace that it's moving. And the reason I did that was specifically so that I can measure where the water is at 0.0 seconds to where it is at 1.0 seconds. And so not only can I measure the width of the canyon, what I do is I stretch a measuring tape along where I think the water line was, and then measure in increments the height and then average it out. But I can also measure the distance traveled over a single second. And using the volume that I come up with, I can find the discharge rate per second during the maximum flow. I can do that for both 2019 and 2021 because I have video of both floods and I can recreate the reference points from 2019, and I have a reference point like this from this year because this was all placed here by the flash flood. This is like very clear evidence that the water reached this height on Tuesday, and the water reached the bottom of the sandbar also. And if I look, they're at the exact same height. And so I could measure it here, but I want to measure on those steps. I might stop this video and then restart it down there so you guys can see what I'm talking about, or I'll just I don't know how I'm going to add a photo to it and so you guys can see what I'm talking about. Go check out my Twitter. You'll see in one of my tweets is a small little waterfall out of a man-made kind of dam-like thing, and that's where I'll be able to measure the floods for now on, because that area is not going to change, right? This flash flood deposited a lot of soil on the ground, and so it's going to interfere with my data, right? If the flood comes through, the depth of the water is going to change. Okay, say it's the water was this high. At the bottom of the river, the elevation changes. And so I can say, oh yeah, well this was, I don't know, 7 feet. But during the actual flash flood, the bottom of the river could have been lower. And so it would really be 8 feet. Well, that concrete thing is not going to change in elevation all that much during the flash floods. You're not going to get a lot of sand that accumulates at the bottom because you got a big waterfall that shoves it away, and it's going to serve as a great reference point for me to measure this flash flood. So that's what I'm going to do right now. That's what I've learned about recording flash floods. I've got a lot to learn. That's why I'm going to school to be a climatologist. But yeah, that's my special interest for this week. And so, half bucket of trash and a great view for taking today's video. Check out this place. I'm going to shut up for a few seconds and just look. Isn't this crazy? Isn't this the coolest place ever? I love it. Day 875, Thursday, December 16th, 2021. After one of the largest flash floods that we've seen in 16 years.